Welcome! In this video series, we'll walk through how ApertureDB workflows simplify end-to-end data operations for multimodal AI applications. Face detection plays a key role across industries, from organizing photo libraries and enhancing security systems. But building a scalable face search pipeline doesn't have to be complex. With ApertureDB's workflow, you can implement face detection and similarity search in just a few clicks. In this demo, we'll walk through how to retrieve faces from images, extract descriptors, aka embeddings, and run similarity searches, all within a streamlined multimodal database. Let's take a look. First, let's ingest the images we'll use for face detection into ApertureDB Cloud. ApertureDB provides workflows that can pull data directly from AWS or GCP buckets. In this demo, I'll ingest images stored in an S3 bucket. Once ingestion is complete, we'll proceed with the face detection workflow. This step scans images stored in ApertureDB, identifies faces, and adds bounding boxes around each one. If the Extract Embeddings option is enabled, the system also generates embeddings for every detected face. During the workflow execution, let's take a closer look at how the face detection workflow operates. The face detection app retrieves images from ApertureDB, where the WF_FaceNet_process property is not set to true. For each of these images, it runs a face detection algorithm to generate bounding boxes around detected faces. Then, it creates descriptors for each face bounding box. These bounding boxes and descriptors are connected together and stored back into ApertureDB. The workflow source code is publicly available on GitHub, making it easy to customize and adapt to your needs. Currently, the face detection library used is PyTorch's MTCNN, and for generating embeddings, the workflow utilizes InceptionRes.NET v1. Now let's review the workflow results using the web UI. We can confirm that 267 bounding boxes and descriptors have been generated across 100 images. If you enable the property view in image search, you'll be able to see both the images and their associated properties together. Next, we'll run a query on the face bounding boxes generated via Jupyter Notebook to find photos containing similar faces. ApertureDB Cloud allows you to connect your notebook to a database instance via workflows. Let's open the face detection notebook on the Jupyter Lab server. First, we'll import the necessary modules for running queries and displaying images. Then, we'll set up the client connection. Next, we'll retrieve the unique IDs of the bounding boxes generated by the face detection workflow. When the workflow runs, each image is assigned a unique WF_SHA-1_hash-ID property. You can use the web UI to look up the SHA-1 hash ID of any image you're interested in. Using the SHA-1 hash ID we obtained, we'll fetch the target image along with the unique IDs of the bounding boxes associated with it. If an image contains multiple bounding boxes, you can identify the one you want by referring to its width and height properties. Now, we'll retrieve the descriptor aka embedding linked to the selected bounding box and store it in face_blobs. Finally, we'll use face_blobs to perform a similarity search and find images containing similar faces. The descriptors generated by the face detection workflow are stored in the WF_FaceNet_processed descriptor set. We'll use the find descriptor command with face_blobs as input to search for the top 5 most similar descriptors within the WF_FaceNet_processed set. Along with each descriptor, we'll also retrieve the associated bounding box and the image linked to that bounding box. This demo highlighted how to navigate ApertureDB's face detection workflow, from extracting image and bounding box metadata to running similarity searches with descriptors. By leveraging bounding box properties and descriptor sets, you can efficiently identify and compare faces across your dataset. This approach supports scalable, multimodal search pipelines for real-world applications. Thanks for watching. To learn more, visit aperturedata.io or scan the QR code to get started.